Hi all, my name is Nicole, and I hail from the world of YouTube Live, where we work on the infrastructure that supports live streaming at YouTube. This includes both what you might think of as regular YouTube and actually also YouTube TV. Today, I'm going to be telling you the story of enhancing RTMP. This is an effort that many were involved in, but I will tell it from the perspective of our involvement as YouTube Live. Alright, so first off, let's level set a bit. Where does the story of YouTube Live start? The very first incarnation of YouTube Live was actually back in 2008. In terms of a few early highlights, in 2012, the London Olympics were live streamed through YouTube. Maybe some of you might remember the Red Bull Stratos event, where an Austrian skydiver jumped from the stratosphere. This jump lasted about 10 minutes and was watched by over 8 million concurrent viewers on YouTube back in 2012. So over the years since then, we have focused on our side on scaling the platform and the infrastructure, and bringing new capabilities to creators across a variety of settings. And when I say a variety of settings, it really spans the whole gamut. We want to enable creators to engage in, laid-back, casual conversation from their mobile phones. And on the extreme other end of the spectrum, we also want to enable professional broadcasters, the workflows of ESPN and ABC and the like. But here at YouTube Live, we also challenge ourselves to enable regular creators to create high-quality streams. We are talking here about streaming in 2K, 4K, HDR, even if you are not a professional TV-style broadcaster, and even if you don't have high upload internet speeds at home. This was the driving goal that led us down the road of enhancing RTMP. Since not all of you may work with live video, I wanted to take a quick moment to point out how the live streaming setup differs from VOD, or video on demand. Live input can come from a variety of different devices. Your camera, your computer screen, but the key thing is that an encoder is always involved to send media data to the server via an ingestion protocol. Now, the protocol used for the ingest step does not need to be the same as the one used to deliver media to the players. In fact, most of the time, they are not the same. And as you can imagine, different protocols have different pros and cons when being used for ingest. So going back to the evolution of YouTube Live, we added different ingestion protocols along the way in order to support the wide variety of use cases on our platform that I explained above. We actually started off with RTMP as our first ingestion protocol. Later in 2017, we added WebRTC to support creators live streaming from their mobile phones. In 2019, we then added HLS support. This enabled us to be the first major platform to bring HDR live streaming to creators. And also, for creators who wanted to use more modern codecs like H.265, we recommended that they send their streams to us via HLS. Now, accepting H.265 meant that creators could send us higher quality, talking like 2K, 4K content at much lower bit rates compared to H.264. This benefits creators with low bandwidth connections, and we really hoped that it would open up high quality, high resolution content to be accessible to more people in terms of creating the content. But as I mentioned, ingestion protocols have pros and cons. HLS has some downsides. It's a high latency protocol, and because it's chunk-based, it can reduce ingestion reliability under poorer network conditions. But most importantly, although it is used heavily for delivery, it's actually not widely available in the encoder ecosystem for ingestion. So we wanted to make creating high-quality content at lower bit rates accessible to creators, but HLS didn't really solve our problem. This led us to sit down and ask ourselves, can we do better in the near term? RTMP is still widely available, and it's widely used for ingestion. It looks like it will be a while before all of this changes. So, as YouTube, is there something we could do for the ecosystem so that we can meet creators where they are at? All right, so we've talked a little bit about YouTube Live, and how we got to a key decision point about what we wanted to do about RTMP. Let's backtrack a little and talk about RTMP. RTMP was developed by Macromedia, and it made its first appearance all the way back in 2002 with the launch of Flash Player 6. In the 2000s, Flash, some of you might remember, was very popular. And so you can imagine that RTMP was heavily used to transport media over the internet. During these years, more platforms also started to accept media via RTMP. And so there was an explosion in tooling and encoder support for RTMP in general. However, today, Flash is officially deprecated, in fact. Its end of life was announced in 2020. So RTMP is basically no longer used for delivery. It's been replaced by HTTP protocols like HLS and Dash. However, because of that explosion of tooling and encoder support back in the 2000s, RTMP remains incredibly popular among the vast majority of streamers for ingestion. In terms of maintenance, Adobe publicly released part of the RTMP spec in 2012, but it has not updated it since then. In 2019, they licensed out the use of RTMP software tools to a company called Veriscope. This is where the story continues. In 2021, YouTube then gets in touch with Veriscope and starts discussing various options to be able to get the RTMP spec updated. Veriscope then reaches out to Slavic, pictured here. Slavic was actually a core member of the team that originally developed RTMP while at Macromedia back around 2000. And funnily enough, Slavic's first reaction was actually surprise. Mild shock, pleasant surprise though. He said he almost couldn't believe that 2 decades later, RTMP continues to be so popular and so highly used. The next step after this is, in 2022, Viovera Software Organization gets founded as a non-profit foundation. Slavic serves as the chairman of Viovera, and the goal of this foundation is to help update the RTMP spec for the benefit of the wider community. Now I'll take a moment to explain a couple things. We usually say we're enhancing RTMP, but to be precise, we're actually also enhancing FLV. Let me explain. So RTMP messages have this message header that you see. This message header is followed by a message payload. Messages can carry metadata, they can carry commands, control messages for communication between the client and the server, they can carry synchronization objects, and of course, they can carry media data. But note that RTMP itself, in the spec, does not actually constrain the media data in the payload. What happens is that RTMP actually leverages Flash Video, aka the FLV container format, for media. Just in case anybody's not familiar, FLV is a fairly lightweight container format. It comprises alternating tags and backpointers. There are 3 types of tags: video tags, audio tags, and script tags for metadata. Each video tag typically contains 1 frame of video. Backpointers specify the size of the preceding tag. In terms of structure, tags, as you can imagine, also have a header and a data payload. But you'll notice that the structure of the RTMP message header actually matches the FLV tag header. You'll also notice that the RTMP message header has a message type ID, and the FLV tag header has a tag type ID. These ID values actually intentionally match between RTMP and FLV for video, audio, and any script metadata when it's encoded by AMF0. Hopefully that makes it clearer then, that when we say that RTMP needs to support more modern video codecs, we actually implicitly mean that FLV, the FLV spec, needs to be updated to support more modern video codecs. So how did we add these additional video codecs? In the original FLV video tag header, the codec ID is specified as 4 bits. Of course, since it's 4 bits, there's a maximum of 15 values. 7 codecs were originally defined. So, as you can imagine, the easiest solution, of course, here is to simply extend the codec IDs up to a maximum of 15. And to start off with, we were prioritizing 3 codecs: AV1, H.265, and VP9. So, of course, we have 8 more values to play with. This should work fine. But the enhancement actually takes a more future-proof approach. It actually provides a mechanism to signal that an extended video header format should be used instead. Within this extended video header, new codecs are specified as 4-character codes, which obviously removes the restriction of having just, 8 more codecs that you can play with, and after that, you're done. Also, by specifying a new extended header format, this provides additional flexibility for, any future changes where you need to possibly provide finer levels of metadata. So we added that, and then the second enhancement that was added was actually to support HDR. Within that same extended header that I mentioned just now, you can specify different packet types. And there was a new packet type called metadata, which was added. Within this metadata packet type, which I know is a fairly generic name, you actually write an AMF string called color info, and after that you write an AMF object. Within the AMF object, you can encode basic properties like color primaries and transfer characteristics, which are important for carrying HDR-related metadata. And you can also encode more advanced properties like minimum and maximum luminance. One thing I wanted to emphasize, while they try to be forward-looking, the enhancements to RTMP and FLV are always backwards compatible with the previous specifications. As an example of a trickier case, here's how the enhancement spec signals to use an extended video header. So actually, from the first 4 bits of the original video tag header, the enhancement says to use the most significant bit of those 4 bits as a Boolean to indicate whether or not an extended header is being used. But the spec is very careful because it ensures that this single bit that's now being used as a Boolean was previously always 0, and therefore is safe to now use in a backwards compatible manner. Alright, so I explained, at a high level what the changes were that were included in the enhancement spec. And in the scheme of things, these are not very complicated changes. That's actually important because we do want the changes to be a light lift for the ecosystem to adopt. And yet, behind the scenes, actually a lot of feedback was involved to bring these enhancements to life. I mentioned ViaVera just now. So ViaVera's software organization actually formally includes Adobe, YouTube, and Twitch as members and sponsors to help update the RTMP spec. But we also had a lot of valuable input from experts both within Google and, importantly, outside of Google. There were many more partners and representatives from across the industry who were involved in critically shaping the spec. This also includes core members of communities like OBS and FFmpeg, and they could provide their expertise and their perspectives from the open source world. And I'll also give a call out that one of the original editors of the RTMP spec from 2012 was also involved in providing critical feedback. Finally, what happens? In March 2023, ViaVera publishes the first enhanced RTMP spec on GitHub as a public beta. This is a huge milestone because it's the first formal Adobe-endorsed update to RTMP's capabilities in over 10 years. Great. So, where are we now? I mentioned earlier that our original objective at YouTube was to see if we could enable creators to send us higher quality streams at lower bit rates while using the workflows and encoders that they were already used to. And the spec enhancement that I just said was published back in March includes support for HDR, and it does include support for the additional video codecs AV1, H.265, and VP9. These are all much more efficient codecs compared to H.264. But in particular, here at YouTube, we were excited about supporting AV1. Scratch that. We were actually extremely excited about AV1. As most of you know, unlike H.265, AV1 is royalty-free, and this makes it extremely attractive for adoption. The AV1 spec was released in 2018, and pretty much since then, we have been excited about it as the way of the future for live streaming. But before we could start accepting it for live, the ecosystem actually had to catch up. In particular, software encoders for AV1 tend to be slow. But for live, obviously this doesn't work because for encoding, you have to keep up in real time. And so what happens? At the end of 2022, the major GPU vendors all have released their first series of cards that support real-time AV1 encoding. And so the pieces are now starting to fall into place. With the advent of these new series of GPUs, YouTube can start accepting AV1. So shortly after ViaVero publishes the enhanced RTMP spec, YouTube releases support for AV1 and H.265 ingest over RTMP. For this, we worked really closely with the incredible OBS community to bring this capability to creators. And just to give you an idea of why we are so excited about bringing this to creators, here's an example of us playing Forza, which is a racing game. Yes, we do play video games at work. This first screenshot is taken at 4K, 60 frames per second, and it's 10 megabit per second bitrate. And it's a racing game, so it's high motion content. And I want you to look at the sky, look at the grass, look at the buildings on the left and the radio tower on the right. And you can see how blocky everything is. And there's lots of encoding artifacts and lots of detail. Now here, this next screenshot is the same frame. It's encoded with AV1, also at 10 megabits per second. And you can see the incredible increase in detail. There's much less evidence of compression artifacts. I'll take this chance to emphasize that, yes, YouTube Live does transcode live streams, but a better quality at ingestion still means that the output is going to look visually better too. Speaking about AV1 just in general, here at YouTube Live, we are at the vanguard of helping to grow and develop this new emerging part of the ecosystem, and we actually strongly hope that other platforms will be able to support this capability soon too, to further spur the growth of the AV1 ecosystem. All right, now, taking a step back. We started off asking ourselves, back in 2021, if we could do our part to move the ecosystem so that creators could send us higher quality streams at lower bit rates using their existing RTMP workflows. And as you can see, in 2023, we did it. But fret not, the story continues. So right now, we are working on getting these changes adopted. In fact, thanks to Jean-Baptiste from FFmpeg and his great team, the video codec extensions are already available in FFmpeg Head for anybody who wants to play with them. And also to give you a special sneak peek, there are new features being worked on for the next version of the spec. These include modern audio codec extensions. We did the video codec extension, so we do also want to extend it for audio. It actually includes multi-track video and audio, and functionality for reconnection. Longer term, we also have representatives on our side involved in shaping a new IETF standard called Media over Quick, and we hope that this will replace RTMP in the further future. To wrap up, I wanted to say a big thank you to the many experts and partners involved in making this happen. RTMP was launched in 2002, the spec was released in 2012, and finally here in 2023, we have the first set of new capabilities in over 10 years. This huge milestone would not have been possible without great collaboration across the industry and ecosystem. So thank you to all of you for making this happen. We hope to also work with everyone to continue to bring more capabilities to creators soon. Wrapping up, I wanted to give a special call out and thank you to Colleen Henry from Meta and Alex Lindsay from Office Hours, who actually helped make introductions and bring people together behind the scenes to make this effort a reality. And also, thank you to Abhinav, the organizer of this conference. We hope that since you worked on RTMP back in the day at Macromedia, that this has actually been a great blast to the past for you. Thank you.